September 7th, 1943. The port of Palermo, Sicily. Commander Giuseppe Fioravanzo of the Regia Marina stands on the damaged harbour wall, watching American cargo vessels unload with mechanical efficiency that defies everything he learned in 30 years of naval service. 17 Liberty ships crowd the waterfront, their identical silhouettes stretching toward the horizon like mass-produced monuments to industrial power. Each vessel disgorges trucks, tanks, artillery pieces, and mountains of supplies onto Italian soil now controlled by Allied forces. Behind him, the skeletal remains of Italian merchant ships rust in the shallow water. Vessels that took 8 months to build, sunk in minutes by Allied bombs and torpedoes. The mathematics haunting Fioravanzo's thoughts are brutal and inescapable. Italy's entire merchant marine, built over decades, lies scattered across the Mediterranean floor. Yet here stand 17 American cargo ships that didn't exist 6 weeks ago, delivering the material superiority that crushed Mussolini's dreams of empire. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. An American logistics officer approaches, clipboard in hand, speaking broken Italian learned from a phrase book. He gestures proudly toward the nearest Liberty ship, the SS John W. Brown, and mentions a number that Fioravanzo initially dismisses as translation error, 42 days. The officer repeats it slowly, making sure the Italian commander understands. This ship, 10,000 tons of steel capable of carrying 2,800 jeeps or 9,000 tons of cargo, was built in 42 days from keel laying to launch. Fioravanzo's response comes in perfect English, honed through pre-war years as a naval attaché in London. That's impossible. Our shipyards require minimum 200 days for similar vessels. The American shrugs with casual certainty that borders on arrogance. We built one in 4 days last year, set a record. These are slow by our standards. The Italian commander stares at the Liberty ships with growing comprehension of something more terrifying than military defeat. His nation lost the war before the first shot was fired, not through failures of courage or strategy, but because Italy never understood the true nature of 20th century industrial warfare. While Mussolini's engineers crafted ships like Renaissance sculptures, one riveted plate at a time, America had transformed maritime construction into factory production that churned out vessels faster than Axis submarines could sink them. The morning sun casts harsh Mediterranean light across 17 identical cargo ships that shouldn't exist, according to every principle of European naval construction. Fioravanzo served in the Great War, watched Italian shipyards struggle to replace tonnage lost to Austrian torpedoes and British mines. The industrial arithmetic of that conflict had been brutally simple. Sink ships faster than enemies could build them, and victory became inevitable. Germany's U-boat campaign nearly succeeded in starving Britain through strategic patience, one merchant vessel at a time. But this war operated under different mathematics. The Liberty ships crowding Palermo harbour represented something unprecedented in maritime history. Mass production applied to ocean-going vessels with ruthless efficiency that violated every sacred principle of European craftsmanship. Each ship identical to its neighbours, built from standardized components manufactured in factories scattered across a continent, then welded together with methods that Italian naval architects considered dangerously experimental. Behind the immediate shock of American productivity lay a deeper crisis of understanding. Fioravanzo and his fellow officers had analyzed the wrong variables. They studied Allied naval tactics, decoded radio intercepts, tracked convoy movements with painstaking detail. What they missed was the foundational truth that modern warfare was decided in factories and shipyards long before fleets engaged in combat. Italy entered the war with approximately 3.5 million tons of merchant shipping, adequate for Mediterranean trade during peacetime, desperately insufficient for sustaining military operations across 3 continents. The Regia Marina's planners understood this vulnerability. Their pre-war projections calculated that Italy needed minimum 7 million tons of merchant capacity to maintain supply lines to North Africa, while defending shipping routes in the Mediterranean. The gap between requirement and reality was supposed to be filled through captured Allied vessels and accelerated construction in Italian yards. Neither assumption survived contact with industrial reality. German U-boats operating from French Atlantic ports achieved devastating success during 1942. Over 8 million tons of Allied shipping sent to the bottom, more than 600 vessels destroyed in a single year. The numbers seem to validate Axis strategy: sink ships faster than they can be replaced, and Allied supply lines would collapse under mathematical certainty. Admiral Karl Dönitz, commanding Germany's submarine fleet, believed he was winning the tonnage war through simple arithmetic of destruction versus construction. What neither German nor Italian naval planners understood was that American industrial capacity operated under entirely different rules. Henry Kaiser, a dam builder and road contractor who had never constructed a ship before 1941, saw what traditional maritime experts refused to believe. Ships weren't crafted monuments requiring months of skilled labor. They were products to be manufactured using assembly line principles pioneered in automobile factories. The British Liberty Ship Programme, initiated in late 1940, had attempted to address the convoy crisis through modified designs emphasizing simplicity over sophistication. British yards reduced construction time from the PERS, peacetime standard of 8 months, to approximately 70 days, a remarkable achievement by European standards. When Kaiser examined British methods during early 1941, he recognized they hadn't gone far enough. 70 days was still too slow to replace the tonnage being destroyed by U-boats operating at the peak of their effectiveness. Kaiser's radical vision rejected incremental improvement in favor of revolutionary transformation. He proposed building cargo ships the way Henry Ford built automobiles. Prefabricated sections manufactured simultaneously in factories across America, then transported to shipyards for final assembly. Welding instead of riveting, reducing construction time while eliminating bottlenecks caused by skilled labor shortages. Most controversially, Kaiser planned to hire workers who had never seen a ship. Women, wounded veterans, African Americans barred from traditional maritime trades, people who could learn specific welding operations in 10 days rather than spending 6 months mastering the comprehensive skills required for riveting. The established shipbuilding industry reacted with alarm masked as professional concern. These weren't merely faster construction methods, but fundamental challenges to maritime tradition stretching back to ancient Phoenicians. Todd Shipyards in New York, Bethlehem Steel in Baltimore, Newport News Shipbuilding in Virginia. These venerable firms had built America's merchant marine through generations of accumulated expertise. They warned that Kaiser's welding techniques were unproven and dangerous. Ship steel wasn't designed to be welded. Brittle fractures could split hulls in half. Lives would be lost. But Kaiser saw what the experts refused to believe, that America's most unsafe manufacturing trick would become the only way to win the war. By June 1942, when Fioravanzo was helping coordinate Italian defences in Sicily, German U-boats were sinking Allied cargo ships faster than traditional methods could replace them. Britain's survival depended on supplies ferried across the Atlantic in merchant vessels being destroyed at unsustainable rates. America needed thousands of cargo ships to support 2 million troops fighting on 2 continents. Traditional shipbuilding required 10 to 12 months per vessel. At that pace, the war would be over before sufficient merchant marine capacity existed to supply Allied forces. The Liberty Ship Programme represented America's industrial answer to strategic catastrophe. Emergency cargo vessels designed for rapid construction using simplified systems and standardized components. 441 feet long, 57 feet wide, displacing 14,000 tons fully loaded. Powered by aging but reliable triple expansion steam engines that could push the vessels to 11 knots maximum speed. Nothing elegant or sophisticated. Just functional cargo capacity built as quickly as human organization and welding torches allowed. Kaiser's first proof of concept emerged in September 1941 when the SS Star of Oregon launched after just 131 days of construction, 100 days faster than industry standard. Maritime establishment dismissed it as beginner's luck that would never be repeated. They'd been building ships the same way since ancient times. Keel first, ribs next, steel plates riveted one by one in methodical climb toward completion. 6 months to train a qualified riveter, months more to season workers into competence. The process demanded patience that America no longer possessed. Kaiser's revolution wasn't born from maritime expertise, but from manufacturing logic learned through building dams and highways. While traditional shipbuilders thought vertically from keel to superstructure, Kaiser envisioned horizontal assembly lines where standardized sections could be prefabricated simultaneously across the country. 250,000 parts manufactured in parts, factories from coast to coast, then transported to shipyards as massive sections weighing up to 250 tons each. Like building with enormous steel blocks, each piece designed to mate perfectly with its neighbors, regardless of which factory produced it or which coast it traveled from. The concept violated every sacred principle of shipbuilding craftsmanship, which was precisely why it worked. The welding gamble represented Kaiser's most audacious break with tradition. For 2 millennia, ships had been riveted. Steel plates overlapped and joined by metal pins hammered through both surfaces, creating thousands of potential leak points but containing structural failures at mechanical joints. Welding fused metal directly, creating continuous seams stronger than the plates themselves. More importantly, welders could be trained in 10 days versus 6 months for riveters. One welder could accomplish the work of 2 complete riveting teams. The mathematics were undeniable, but mathematics had never sailed through North Atlantic storms. The human element of Kaiser's revolution proved as radical as his technical innovations. With men being drafted faster than shipyards could replace them, Kaiser hired the previously unemployable, women who'd never held industrial tools, wounded veterans missing limbs, disabled workers dismissed by other employers, African Americans barred from skilled trades by union prejudice. The shipyards became accidental laboratories of American democracy, where performance mattered more than pedigree. Each worker learned one specific task, achieving precision through repetition rather than years of apprenticeship. Rosie the riveter became Wendy the welder, and production lines hummed with voices speaking dozens of languages united by common purpose. By early 1943, Kaiser had reduced construction time from the industry standard of 640,000 labor hours to 352,000 hours per ship. His average completion time dropped to 70 days, then 50, then 39 days. The SS, Robert E. Peary stunned observers by launching after just 4 days, 15 hours, and 29 minutes of assembly, a feat so extraordinary that naval inspectors initially refused to believe the documentation. But the number that truly mattered wasn't the record-setting sprint. It was the sustainable pace. By summer 1943, when Fioravanzo watched American logistics transform Sicily into Allied supply base, Kaiser's yards and competitors working under his revolutionary methods were launching 3 Liberty ships daily, 18,000 tons of cargo capacity entering service every 24 hours, 1 million tons monthly, 12 million tons annually. The tonnage war that German admirals believed they were winning through U-boat attrition had already been decided in Kaiser's favor through industrial mathematics that Axis planners never comprehended. Standing on Palermo's damaged waterfront, watching American efficiency transform Italian defeat into Allied logistics hub, Fioravanzo understood that everything he'd learned about maritime warfare was obsolete. The Italian Navy entered the conflict with ships built through traditional methods requiring 8 months per vessel. When those ships were sunk, and Italian industrial capacity couldn't replace them fast enough, the Regia Marina withered through simple attrition. Not from lack of courage or strategic brilliance, but from fundamental misunderstanding of how 20th century industrial nations prosecuted total war. The Liberty ships unloading supplies with mechanical precision weren't just cargo vessels. They were physical manifestations of manufacturing philosophy that treated complexity as organizational challenge rather than insurmountable barrier. Each identical ship represented industrial DNA from across a continent. Steel from Pennsylvania, engines from Detroit, electronics from Massachusetts, lumber from Oregon. Assembled by workers who 18 months earlier had been housewives, farm laborers, and shop clerks. People who learned specific welding operations in days, then performed those operations with precision that exceeded traditional craftsmanship. Fioravanzo had studied naval warfare at the Italian Naval Academy in Livorno. He understood fleet tactics, gunnery procedures, submarine deployment strategies. What his education never addressed was the reality that modern conflicts were won in factories and shipyards long before navies engaged in combat. The elegant cruisers and battleships Italy built with such pride were strategic irrelevancies when America could replace every sunken cargo ship with 3 new vessels before the wreckage settled on the ocean floor. The American logistics officer continued his cheerful explanation of Liberty ship production statistics, apparently unaware that each number drove another nail into the coffin of European naval prestige. Peak monthly production reached 150 vessels in December 1942. 3,000 tons of cargo capacity launched daily, enough replacement tonnage to offset U-boat successes with surplus capacity for expanding Allied supply lines. The mathematics of industrial attrition that should have favored Germany's submarine fleet had been reversed through manufacturing innovation that traditional maritime nations never attempted. Kaiser's revolution in shipbuilding represented something more profound than faster construction techniques. It demonstrated that American industrial capacity could expand to meet any challenge when necessity eliminated luxury of conventional thinking. While European shipyards employed craftsmen who spent careers mastering riveting skills and understanding the subtle behaviors of ships in heavy seas, Kaiser's yards treated each vessel as a collection of standardized components, assembled by workers performing specific repetitive tasks, learned in days. The quality concerns that European experts raised about welded construction proved legitimate. By winter 1943, Liberty ships began suffering catastrophic structural failures. The SS John P. Gaines broke apart in the Atlantic. The SS Schenectady split completely in half while docked in calm water. Over 1,000 ships developed cracks ranging from minor surface fractures to complete hull failures. The welded seams that enabled rapid production were splitting apart, and men were dying. Kaiser faced professional and personal crisis that threatened to vindicate every traditional shipbuilder who had warned against his revolutionary methods. But what the subsequent investigation revealed was that welding hadn't caused the problem. It had exposed fundamental flaws in ship steel chemistry that riveted construction had masked for centuries. The material used in both welded and riveted vessels contained sulfur levels that were dangerously high and manganese, content inadequately low. Riveted construction had hidden these weaknesses because mechanical joints acted as crack arresters. Welding eliminated those natural barriers, creating continuous failure paths that revealed brittleness which had always existed. The engineering solutions implemented during 1944 proved that American industrial capacity could adapt and overcome even catastrophic technical failures. Naval architects redesigned Liberty ship construction to include riveted crack arrestor seams at critical stress points. All corners on windows, doors, and hatches were rounded to eliminate stress concentrations. Victory ships incorporated these lessons from the beginning, featuring improved hull designs better able to handle fatigue loading and thermal stress. By the time Fioravanzo stood watching American cargo vessels unload in Palermo, Kaiser's methods had been refined through painful experience into reliable manufacturing process that combined welding speed advantages with mechanical joints failure containment benefits. The Liberty ships crowding Sicily's harbours represented industrial learning curve compressed into months, problems identified and solved with wartime urgency that turned potential disaster into validated success. What Italian naval commanders couldn't grasp was the fundamental difference between their nation's industrial capacity and America's manufacturing potential. Italy's shipyards employed skilled craftsmen, working traditional methods that produced excellent vessels when time and resources allowed proper construction. But Italian industry lacked the organizational systems, standardized processes, and mass production infrastructure necessary for total war. Building ships one at a time, regardless of individual quality, guaranteed strategic failure when confronting enemy capable of launching 3 replacement vessels daily. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The sun climbed higher over Palermo harbour, casting sharp shadows from Liberty ships that dominated the waterfront like industrial monuments to American power. Fioravanzo watched American soldiers unload supplies with casual efficiency, their movements reflecting the same systematic organization that built these vessels in weeks rather than months. Everything was standardized, interchangeable, replaceable. Trucks, identical to thousands of others rolling off Detroit assembly lines. Ration crates stacked in precise dimensions for maximum storage efficiency. Even the soldiers seemed products of industrial system, each trained for specific roles rather than comprehensive military expertise. The Italian commander had entered the war believing that European military tradition, ancient Roman discipline, and Mediterranean naval heritage provided advantages that crude American industrial power couldn't overcome. 3 years of brutal reality had demolished those comfortable assumptions. The Liberty ships unloading in conquered Italian harbour represented truth more devastating than military defeat. Italy lost the war in factories and shipyards, not on battlefields. The contest was decided before the first shots were fired, determined by industrial systems and manufacturing philosophies that Italian planners never understood until American cargo vessels delivered the physical proof of their miscalculation. 42 days from keel laying to launch. The number haunted Fioravanzo as he walked back toward what remained of Italian naval headquarters. Not because it seemed impossible. After watching 17 Liberty ships transform Palermo into Allied supply depot, he believed the American statistics. What tormented him was the recognition that his entire professional life had been rendered obsolete by people who understood that modern warfare was a manufacturing problem to be solved through systematic organization rather than heroic naval tradition to be honored through craftsmanship. Somewhere across the Atlantic, Henry Kaiser was already building the next generation of cargo vessels, each one constructed faster and more efficiently than the last. The welding revolution that traditional shipbuilders had dismissed as dangerous experimentation had become foundation for American industrial supremacy. And Commander Giuseppe Fioravanzo, standing amid ruins of Italian naval power, finally understood that his nation never had a chance. The ancient Phoenicians would have recognized the scene at Todd shipyards in Brooklyn during winter 1942. Workers swarmed over skeletal hull, each riveting team hammering steel plates one by one in methodical climb from keel to deck that had defined shipbuilding for 20 centuries. The rhythmic percussion of pneumatic hammers echoed across East River as riveters drove heated pins through overlapping steel plates, then flattened the protruding ends with practiced precision. 6 workers per team, heater, catcher, bucker, riveter, each requiring 6 months of training to achieve competence. The hull would take 8 months to complete, assuming no delays for weather, material shortages, or inevitable injuries that plagued industrial construction. 3,000 miles west, Henry Kaiser's Richmond shipyard operated under entirely different principles. Instead of thinking vertically from keel upward, Kaiser reimagined ship construction horizontally. Massive prefabricated sections built simultaneously in factories across America, then transported by rail for final assembly. The bow section arrived from steel mill in Pennsylvania. Engine mounts were fabricated in Detroit using automotive assembly techniques. Superstructure components rolled off production lines in Seattle, each piece tagged with numbers corresponding to precise positions in the final vessel. The approach violated every sacred tradition of maritime construction, which was exactly why it worked. Kaiser's most radical innovation wasn't organizational, but metallurgical. Welding had existed for decades as repair technique used, sparingly to patch damaged plates or seal minor leaks. But Kaiser proposed fusing entire hulls with continuous welded seams, eliminating the overlapping plates and thousands of rivets that traditional construction required. The implications were staggering. Welded ships used significantly less steel because plates didn't need to overlap. They moved faster through water because rivet heads no longer projected into flow, creating drag. Most importantly, welding could be taught in 10 days versus 6 months for riveting, and one skilled welder could accomplish work previously, requiring 2 complete riveting teams. The human mathematics of Kaiser's revolution proved as compelling as technical advantages. Traditional shipbuilding demanded armies of skilled craftsmen trained through years of apprenticeship, exactly the demographic being drafted into military service faster than yards could replace them. Kaiser's modular approach required workers to master single repetitive tasks rather than comprehensive maritime expertise. A housewife from Oklahoma could learn to weld superstructure joints in 1 week. A wounded veteran missing his left arm could operate overhead cranes with mechanical precision. Disabled workers dismissed by other employers found meaningful roles in Kaiser's assembly lines, their supposed limitations irrelevant when jobs were designed around human capabilities rather than traditional assumptions. The workforce transformation at Richmond Shipyard defied every convention of American industrial employment. Women comprised 30% of Kaiser's workers by early 1943, many experiencing steady wages and industrial responsibility for the first time in their lives. African Americans found skilled positions previously barred by Union prejudice, their welding torches burning as bright as anyone's. Veterans missing limbs, immigrants speaking broken English, teenagers too young for military service. Kaiser's yards became accidental, laboratories of democratic capability, where performance mattered more than pedigree or appearance. The technical precision of modular construction demanded revolutionary thinking about standardization and quality control. Each Liberty ship contained exactly 250,000 individual components, from massive engine blocks to tiny electrical fittings. Every part had to mate perfectly with its designated partner, regardless of which factory produced it or which coast it traveled from. Kaiser implemented automotive-style tolerances and inspection procedures, creating the first truly interchangeable ships in maritime history. A rudder manufactured in Baltimore would fit perfectly on hull assembled in California. Engine parts from Detroit were guaranteed compatible with transmissions from Chicago. The standardization meant Liberty ships could be repaired at any Allied port using components manufactured anywhere in America. The welding revolution required completely rethinking steel chemistry and thermal properties. Riveted construction had hidden fundamental flaws in ship steel for centuries. Plates joined mechanically rather than metallurgically, with overlapping sections that contained cracks at joint boundaries. Welding exposed steel to temperatures exceeding 2,000 degrees Fahrenheit, fundamentally altering molecular structure in ways that maritime engineers barely understood. The fused seams created continuous metal surfaces where stress could distribute more evenly, but also where cracks could propagate unimpeded if base material proved inadequate. Kaiser was betting America's merchant marine on metallurgy that shipbuilders had never tested at scale. Quality control in Kaiser's yards resembled automotive production more than traditional shipbuilding. Each welded seam underwent X-ray inspection to detect internal flaws invisible to surface examination. Workers rotated between stations to prevent fatigue-induced errors. Prefabricated sections arrived with detailed inspection certificates documenting every dimension and material property. The systematic approach eliminated craftsmanship variables that made traditional ships unique and potentially flawed. Every Liberty ship would be essentially identical, built to specifications so precise that components were interchangeable between vessels. The production acceleration achieved by modular construction and welding assembly bordered on supernatural. Where traditional yards completed perhaps 4 ships annually, Kaiser's Richmond facility was launching vessels weekly by summer 1943. The prefabrication network spanning the continent meant that multiple ships could be under construction simultaneously. Bow sections being formed in Pennsylvania while engine mounts were machined in Michigan and superstructures took shape in Washington. When components converged at final assembly points, construction became matter of precisely choreographed connection rather than laborious fabrication from raw materials. The established shipbuilding industry watched Kaiser's revolution with growing horror masked as professional skepticism. These weren't merely faster construction methods, but fundamental challenges to maritime expertise accumulated over millennia. Welded seams had never been tested in North Atlantic storms. Modular construction eliminated the subtle adjustments that master shipwrights made during traditional assembly. The workforce lacked generational knowledge about how ships behaved in heavy seas. Kaiser was conducting the largest metallurgical experiment in history, using vessels that would carry American lives across submarine-infested oceans. And nobody really knew whether welded hulls would hold together when it mattered most. The competition between Kaiser's shipyards became spectacle that drew reporters from across America by spring 1943. Richmond Shipyard No. 3 had shattered its own record so frequently that construction times seemed to exist in freefall. Each launch ceremony celebrated achievements that would have been impossible the previous month. The first Liberty ship had required 124 days from keel laying to launch. By summer, Kaiser's average had dropped to 39 days. Then Oregon Shipbuilding Corporation in Portland completed the SS Joseph N. Teal in 10 days, a feat so extraordinary that Navy inspectors initially refused to believe the documentation. Kaiser's response was characteristically audacious. He would build a ship in less than 1 week, the SS Robert E. Peary became Kaiser's ultimate proof of concept, a vessel whose construction timeline challenged fundamental laws of industrial manufacturing. Assembly began on Sunday, November 8, 1942, with prefabricated sections converging on Richmond from across the continent. The bow section had been welded in Pennsylvania. Engine mounts arrived from Detroit on specially designed railroad cars. Superstructure components rolled into the yard from Seattle, each piece tagged with numbers corresponding to precise positions in final vessel. By Thursday evening, November 12th, the completed ship was sliding down the ways into San Francisco Bay. 4 days, 15 hours, and 29 minutes after the first keel plate had been positioned, the achievement represented more than speed. It was industrial choreography executed with precision that bordered on supernatural. 3 shifts of workers operating around the clock, each team performing specialized tasks with mechanical efficiency. Welders fusing seams with tolerances measured in hundredths of an inch. Crane operators positioning sections weighing hundreds of tons with mathematical precision. Electricians installing miles of wiring through prefabricated conduits. Painters applying protective coatings while final assembly continued around them. The production miracle unfolding across Kaiser's 7 shipyards defied every assumption about manufacturing capacity and human capability. By 1944, Kaiser and his competitors were launching 3 Liberty ships daily, more vessels than entire American maritime industry had produced annually during peacetime. The scale was staggering. Nearly 1,500 vessels rolling down Kaiser's ways alone, representing 27% of all U.S. Maritime Commission construction during the war. Each ship carried industrial DNA of a continent: steel from Pennsylvania, engines from Michigan, electronics from Massachusetts, lumber from Oregon. Assembled by workers who 18 months earlier had never seen welding torch or operated crane. Richmond transformed from sleepy Northern California town into bustling industrial metropolis almost overnight. Population exploded from 20,000 to over 100,000 as workers flooded in from across America, drawn by wages higher than anything available in their home states. Kaiser's yards operated around the clock. 3 shifts covering every hour of every day, with welding sparks visible from San Francisco 20 miles away. The shipyards became cities unto themselves, complete with medical facilities, child care centers, and housing developments constructed as rapidly as the ships themselves. Workers who had never earned more than subsistence wages found themselves with steady paychecks, and employer-provided healthcare through Kaiser's revolutionary prepaid medical program. What began as practical solution to shipyard injuries evolved into Kaiser Permanente, one of America's first health maintenance organizations. The concept that employers should provide comprehensive medical coverage for workers became a model that influenced American healthcare systems for generations. Innovation born from wartime necessity that outlasted the conflict itself. The human element of Kaiser's achievement proved as remarkable as technical innovations. Women comprised nearly 30% of his workforce by 1943, many working industrial jobs for the first time while their husbands served overseas. African Americans found skilled positions previously barred by union discrimination, their welding certifications carrying same authority as any workers. Wounded veterans discovered that missing limbs didn't prevent them from operating cranes or managing prefabrication schedules. The shipyards became accidental laboratories of American equality, where performance mattered more than prejudice and capability counted more than convention. Kaiser's competitive advantage extended far beyond speed to cost efficiency that revolutionized maritime economics. His ships were completed in 2/3 the time at 1/4 the cost of traditional shipyards, margins that made conventional construction methods obsolete. The secret lay in standardization and mass production techniques borrowed from automotive manufacturing. Identical components produced simultaneously across the continent, then assembled with mathematical precision at final construction sites. Labor costs plummeted when workers mastered single tasks rather than comprehensive maritime skills. Material waste disappeared when every plate and beam was cut to exact specifications before reaching shipyard. The catchphrase of the era captured both urgency and audacity of Kaiser's mission. Build ships faster than enemies can sink them. German U-boats were destroying Allied merchant vessels faster than traditional yards could replace them, creating race between American industrial capacity and Axis naval power. Each day's delay meant additional cargo ships resting on ocean floors, their crews dead, and their supplies feeding fish instead of Allied armies. Kaiser's assembly lines represented America's industrial immune system, generating replacements faster than enemies could destroy them. The mathematics were simple but stark: produce or perish. The celebration surrounding each launch masked enormous technical risks Kaiser was accepting with every welded hull. No one had tested Liberty ship construction techniques in North Atlantic storms. The continuous welded seams that enabled rapid assembly created potential failure points unknown in riveted construction. Steel chemistry optimized for mechanical joining might behave unpredictably when fused at welding temperatures. Kaiser was conducting the largest metallurgical experiment in maritime history, using vessels that would carry American lives through submarine-infested waters. Every launch represented bet that American industrial innovation could overcome centuries of maritime tradition. Production efficiency reached levels that seemed to violate physical laws. By late 1943, Kaiser's yards were launching completed vessels faster than some traditional facilities could install engines. The Robert E. Peary's 4-day construction time meant that every component from massive propeller shafts to tiny electrical fittings had been manufactured, transported, and installed with precision, approaching perfection. Any delay, any misfit, any quality problem would have extended construction time. The achievement required coordination between hundreds of suppliers across continent, each delivering components that had to mate perfectly with parts manufactured thousands of miles away. The impossible had become routine at Kaiser's shipyards, where daily launches created rhythm of industrial achievement that redefined American manufacturing capability. Workers arrived each morning knowing they would complete tasks that had been considered impossible just months earlier. Welders fused seams with precision exceeding traditional riveting. Crane operators positioned 250-ton sections, with tolerances measured in inches. The assembly lines hummed with confidence of people who had discovered they could accomplish anything when survival demanded excellence. Kaiser hadn't just revolutionized shipbuilding, he had proven that American industrial capacity could expand to meet any challenge when necessity eliminated luxury of conventional thinking. But the crisis that erupted during winter 1943 and 44 would test whether his revolutionary methods could survive contact with physics they hadn't fully understood. The radio message from SS John P. Gaines reached Coast Guard headquarters at 3:17 a.m. on November 14, 1943. The transmission was brief and chilling. Ship breaking apart, hull fracturing amidships, 10 souls lost, abandoning vessel. Within hours, similar distress calls crackled across Atlantic shipping lanes as Liberty ships began suffering catastrophic structural failures that defied every principle of naval architecture. The SS Schenectady provided the most horrifying example, a crack racing down both sides of hull to keel with explosive speed. The ship's midsection turning skyward, while bow and stern sections plunged deeper into frigid North Atlantic waters. The welded seams that had enabled Kaiser's production miracle were splitting apart like paper, and men were dying in the darkness. The scope of crisis became apparent as reports flooded into Washington throughout brutal winter of 1943 and 44. Over 1,000 ships developed cracks ranging from minor surface fractures to complete structural failure. 190 vessels sustained serious fractures that compromised their seaworthiness. A dozen broke completely in two, their crews facing choice between lifeboats in freezing seas or riding hull sections to ocean floor. The mathematical horror was inescapable. Liberty ships were failing at rates 4 times higher than traditional riveted vessels. Kaiser's revolutionary construction methods weren't just failing, they were killing sailors with mechanical precision. The technical investigation launched in April 1943 revealed metallurgical nightmares hidden within Kaiser's welded hulls. Secretary of Navy Frank Knox appointed board to investigate design and construction methods of welded steel merchant vessels, a bureaucratic response to engineering catastrophe that was costing nation $50 million and irreplaceable lives. British metallurgist Constance Tipper emerged as investigation's most crucial figure, her crystallographic expertise enabling her to read fracture surfaces like crime scenes. What she discovered challenged fundamental assumptions about steel behavior that had guided shipbuilding for centuries. The steel itself was fatally flawed, its chemistry optimized for riveted construction where mechanical joints contained crack propagation. Sulfur content was dangerously high, while manganese remained inadequately low, creating internal weaknesses that became catastrophic when exposed to welding temperatures exceeding 2,000 degrees Fahrenheit. The molecular structure that performed adequately when plates were mechanically fastened became brittle and unpredictable when metallurgically fused. Kaiser's welders, trained in 10 days rather than traditional 6-month apprenticeships, created microscopic flaws during seam formation, imperfections that became fracture initiation points under stress. The welded hulls that enabled rapid construction also created continuous failure paths where cracks could race unimpeded from bow to stern. Traditional riveted construction had masked this behavior for centuries because cracks stopped at joints between overlapping plates. Welding eliminated those natural crack arresters. The most insidious enemy proved to be temperature itself. North Atlantic waters transformed steel from ductile metal into glass-like material through phenomenon called ductile to brittle transition. Steel that bent under stress in warm conditions shattered explosively when cooled below critical temperatures. Square hatch corners, designed for manufacturing convenience, became stress concentrators that initiated failures. Ships were breaking apart under stresses their designers never anticipated. The human cost mounted throughout winter as more vessels succumbed to structural failures that seemed to follow no predictable pattern. Ships broke apart while riding at anchor in calm seas. Others survived North Atlantic storms, only to fracture while loading cargo in protected harbours. The SS Pendleton split completely in half off Cape Cod, requiring one of most dangerous Coast Guard rescues in maritime history. Crews began reporting ominous creaking sounds from hulls under stress. the steel itself crying warnings that welded construction had revealed flaws hidden for millennia. Kaiser faced professional and personal crisis that threatened to destroy his reputation and vindicate every traditional shipbuilder who had warned against his revolutionary methods. The man who had built Hoover Dam and revolutionized American construction found himself accused of murdering sailors through reckless experimentation with unproven techniques. Maritime unions demanded immediate cessation of welded ship construction. Navy officials who had reluctantly accepted Kaiser's production methods now questioned whether speed was worth cost in human lives. The technical truth emerged slowly as metallurgists like Constance Tipper dissected failed hulls with scientific precision that bordered on forensic investigation. The problem wasn't welding itself, but interaction between flawed steel chemistry, inadequate quality control, and environmental conditions that traditional construction had never confronted directly. Inexperienced welders created internal defects during seam formation. Poor steel composition made hulls brittle at low temperatures. Square corners concentrated stresses beyond material limits. The failures represented perfect storm of metallurgical ignorance, masked by construction speed that left no time for comprehensive testing or quality improvement. The winter of 1943 became crucible that tested whether American industrial innovation could overcome its own hubris. Each structural failure provided additional data about steel behavior under conditions that peacetime construction had never encountered. Naval architects began understanding that welded construction required fundamentally different approaches to materials science, quality control, and structural design. The ships breaking apart in Atlantic storms were inadvertently conducting largest metallurgical experiment in maritime history. Their failures teaching lessons that would revolutionize materials engineering for generations. Kaiser's revolutionary construction methods hadn't caused the steel chemistry problems that led to catastrophic failures. They had simply exposed flaws that riveted construction had hidden for centuries. The welding process revealed brittleness that had always existed but had been contained by mechanical joints that arrested crack propagation. The crisis represented not failure of innovation, but painful discovery that traditional materials were inadequate for modern construction techniques. American shipbuilding was learning the most expensive lesson in industrial history. Revolutionary manufacturing methods demanded equally revolutionary understanding of material science, and the education was being paid for in human lives scattered across floor of North Atlantic. The final report from board to investigate design and methods of construction of welded steel merchant vessels arrived at Navy Department in January 1946. Its conclusions vindicated Henry Kaiser in ways that transformed national understanding of both metallurgy and industrial innovation. 970 of 4,694 welded merchant ships had sustained fractures during wartime service. A sobering statistic that nonetheless represented survival of over 3,700 vessels that had carried supplies enabling Allied victory. The board's most significant finding challenged every assumption about Kaiser's responsibility for failures. Welded construction hadn't caused the problem, but had exposed fundamental flaws in ship steel chemistry that riveted construction had masked for centuries. Constance Tipper's metallurgical analysis provided scientific foundation for Kaiser's vindication, her crystallographic expertise revealing that steel composition itself was true culprit. The material used in both welded and riveted ships contained sulfur levels that were dangerously high and manganese content inadequately low, creating internal weaknesses that became catastrophic under stress. The engineering solutions implemented during 1944 proved that American industrial capacity could adapt and overcome even most catastrophic technical failures. Naval architects redesigned Liberty ship construction to include riveted crack arrestor seams at critical stress points, combining speed advantages of welding with failure containment benefits of mechanical joints. All corners on windows, doors, and hatches were rounded to eliminate stress concentrations that had initiated many fractures. Victory ships incorporated these lessons from beginning, featuring less rigid hull designs better able to handle fatigue loading and thermal stress. The improvements were implemented with characteristic American speed. New construction standards appeared within months of identifying problems. Quality control measures instituted after winter crisis of 1943 transformed welded ship construction from experimental technique to reliable manufacturing process. Every welder underwent additional training focused on preventing internal defects that had initiated many failures. X-ray inspection became mandatory for critical seams, revealing flaws invisible to surface examination. Steel chemistry standards were revised to ensure adequate manganese content and reduced sulfur levels. The statistical vindication of Kaiser's methods became undeniable as war's end enabled comprehensive analysis of Liberty ship performance. Of 2,710 Liberty ships built, only 200 were lost to enemy action, a survival rate that testified to both their structural adequacy and their strategic importance in winning the war. The vast majority served faithfully throughout conflict, carrying millions of tons of supplies across submarine-infested oceans. Many continued operating for decades after war, their welded hulls proving as durable as traditional riveted construction once steel chemistry problems were corrected. The technological legacy of Liberty ship failures extended far beyond maritime engineering to revolutionize understanding of material science and structural design. The systematic study of crack formation and propagation initiated by crisis evolved into discipline of fracture mechanics, fundamentally changing how engineers approached structural analysis across all industries. Steel manufacturers developed alloys with vastly improved resistance to brittle fracture, incorporating lessons learned from analyzing hundreds of failed ship hulls. The welding techniques perfected under wartime pressure became standard practice in construction, shipbuilding, and manufacturing industries worldwide. Commander Giuseppe Fioravanzo returned to Palermo harbor in summer 1945, 3 months after Germany's surrender and weeks before Japan's capitulation. The waterfront had been rebuilt with American efficiency, its damaged facilities replaced by modern cargo handling equipment. Liberty ships still crowded the docks, though now they carried occupation supplies rather than invasion equipment. The mathematics that had haunted him in 1943 had only become more stark with time and comprehensive data. Total Liberty ship production reached 2,710 vessels. 741 built by Kaiser's yards alone. 18 ships launched for every one lost to enemy action. The tonnage war that German admirals believed they were winning through U-boat attrition had been decided by industrial mathematics that Axis planners never comprehended. America built Liberty ships faster than German torpedoes could sink them, then continued building until replacement tonnage exceeded losses by margins that made Axis strategy irrelevant. The human legacy proved as enduring as technical innovations. The healthcare system born in Kaiser's shipyards continued serving millions of Americans decades after last Liberty ship slid down ways. Kaiser Permanente, originally created to provide medical care for shipyard workers, evolved into one of nation's largest healthcare organizations. The prepaid medical coverage that had been revolutionary during wartime became model for employer-provided health insurance that defined American benefit systems for generations. The final vindication of Kaiser's vision came not from technical analysis or statistical studies, but from recognition that his unsafe methods had been only way to achieve the impossible. Traditional shipbuilding techniques, however safe and time-tested, could not have produced vessels fast enough to replace those being sunk by German submarines. At conventional construction rates, Britain would have starved before American industrial capacity could supply merchant marine necessary for Allied victory. Kaiser's willingness to accept unknown risks with welded construction enabled America to build ships faster than enemies could sink them, transforming industrial capability into strategic advantage that helped win the war. Fioravanzo stood on Palermo waterfront one final time before returning to his duties helping rebuild Italian merchant marine. The Liberty ships that had shocked him 2 years earlier no longer seemed impossible or even remarkable. They were simply reality of how modern industrial nations prosecuted total war. The lesson Italy had learned at terrible cost was that 20th century conflicts were decided in factories and shipyards long before armies engaged on battlefields. Maritime tradition, ancient Roman discipline, and Mediterranean naval heritage provided no advantages against enemy whose industrial systems could manufacture victory faster than opponents could comprehend the transformation occurring. The steel plate being lifted by cranes at Richmond Shipyard No. 3 in final days of war represented both ending and beginning. The keel plate for what would be among last Liberty ships, positioned as previous vessel touched water for her maiden voyage. The production line that had seemed impossible in 1941 had become routine by 1945, its rhythm as steady as American industrial heartbeat. Kaiser had taught his nation that sometimes most dangerous path forward was only route to survival, and that American innovation could overcome any technical challenge when necessity eliminated luxury of conventional thinking. The impossible had become inevitable, one welded seam at a time, 42 days from keel laying to launch. The number that had seemed like translation error to Italian naval commander in September 1943 now stood as testimony to what American industrial capacity could achieve when survival demanded excellence. The Liberty ships that crowded every Allied harbour from Pacific to Mediterranean weren't just cargo vessels. They were physical proof that manufacturing philosophy emphasizing systematic organization over individual craftsmanship could produce miracles when properly applied. Kaiser's revolution in shipbuilding represented something more profound than faster construction techniques. It demonstrated that complexity was organizational challenge rather than insurmountable barrier, that ordinary people trained in days could perform tasks previously requiring years of apprenticeship. That standardization and mass production could generate consistent quality, exceeding traditional craftsmanship. These lessons extended far beyond maritime construction to reshape every category of American manufacturing in post-war economy. The welding techniques that traditional shipbuilders had dismissed as dangerous experimentation became foundation for modern industrial construction. The healthcare systems born from shipyard necessity evolved into comprehensive employer benefit programs. The workforce integration that occurred accidentally through wartime emergency demonstrated that women, minorities, and disabled workers could perform skilled industrial tasks when given opportunity and proper training. Kaiser's shipyards became templates for American industrial democracy, where performance mattered more than prejudice. Standing amid the Liberty ships that delivered Allied victory, Commander Fioravanzo finally understood the profound irony that would haunt Italian naval officers for generations. His nation entered war believing that European military tradition and Mediterranean naval heritage provided advantages that American industrial power couldn't overcome. Italy lost not through failures of courage or strategy, but because Italian planners never understood that modern warfare was manufacturing problem to be solved through systematic organization. The contest was decided before first shots were fired, determined by industrial systems and manufacturing philosophies that transformed impossibility into routine production schedule. 42 days. The number represented more than construction timeline. It symbolized the gulf between old-world craftsmanship and new-world mass production, between naval tradition spanning millennia and industrial innovation spanning months, between believing ships were monuments to be crafted and understanding they were products to be manufactured. The Liberty ships, built in weeks rather than months, hadn't just won the tonnage war. They had rewritten fundamental rules of how complex things get built, proving that American industrial capacity could expand to meet any challenge when survival eliminated luxury of conventional thinking. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.